In this problem, we're supposed to find the external path length for the binary search tree for the word centennial state. So let's start with our root node of C. Now we look at E. E is greater than C, so we go to the right. Now we look at N. N is greater than C, and it's greater than E, so we go here. Now we look at T. T is greater than C, so we go to the right. It's greater than E, so we go to the right, and it's greater than N, so go to the right, and we put a T. Now we look at E. E is greater than C, so we go to the right, and now E is the same as E, so we go to the left when something's the same. Now we look at N. N is greater than C, so we go to the right. N is greater than E, so we go to the right, and then N is the same as N, so we go to the left here. Then for that next N, we're going to follow the same exact path and end up going to the left here. Now we're at I. So I is greater than C, so we go to the right. I is greater than E, so we go to the right. I is less than N, so we go left. I is less than N, so we go left. And I is less than N, so we go left. Now we're at A. A is less than C, so we can just immediately go to the left. Now we're at L. L is greater than C. L is greater than E. L is less than N. L is less than N. L is less than N, but L is greater than I. So here we go, L. Now we do S. S is greater than C, S is greater than E, S is greater than N, but S is less than T. So right here, we're going to go to the left, or put an S. Now we do T. T is greater than C, T is greater than E, T is greater than N. T is the same as T, so we go to the left here, but T is greater than S. So here we go to the right. Now we do A. So A is less than C, A is less than C, and A is the same as A, so we go to the left. Now we do T again, so we're going to follow that same path that we did before. T is greater than C, T is greater than E, T is greater than N, T is the same as T, so here we go to the left. T is greater than S, so we go to the right, and then T is the same as T, so here we go to the left. And then finally, we're going to do that E. So E is greater than C, E is the same as E, so we go to the left here, and then we go to the left here again, because E is the same as E. So now we've made our tree, but we need to figure out what the external path length is. And the first step to doing that is figuring out what the internal path length is. So first, let's find out how many nodes we have at each level of the tree. So this is level 0, this is level 1, 2, 3, 4, 5, 6. So at level 0, we have 1 node. At level 1, we have 2 nodes. At level 2, we have 3 nodes. Then we have 3 nodes again. Then we have 2 nodes. Then we have 2 nodes. Then we have 2 nodes. So we multiply these numbers together. Those are multiplication signs. And here we have 0, 2, 6, 9, 8, 10, 12. So we add those all up and we get 47. So the external path length is the internal path length, which we just calculated, times 2n, where n is the number of nodes. So we know the internal path length is 47, and we know the number of nodes is 15. So when we do out that algebra, we get that the final answer is 77, and that is the external path length.